Hey everybody, this is Michael with Systems of Human Performance. Today I'm doing another read along, this time talking about the topic of quality function deployment. You might recall that this is article number 3 in a 4-part series dealing with product development and product design. What quality function deployment is, and this tool that we're going to encounter called the House of Quality, is it's essentially a mapping exercise to make sure that we understand that what the customer wants in terms of their desires and the performance characteristics of the Kano model. We want to make sure that those get mapped correctly to engineering specifications that they're actually going to be used to create tolerances and manufacture this thing so that the customer can purchase and enjoy it. So this is a really kind of more technical piece, but I think you'll see why it's important and the value associated with it. I'll make one more caveat before we get started, that we use this thing called the House of Quality, and we're going to just be looking at a piece of that today, but I have some pictures in this article, so if you're listening to an audio-only version of this, you might miss a little bit of the explanation here, and I would encourage you to go to the Substack and pull it up or follow along with this podcast, the video anyway. Okay, with that, let's go ahead and get started with the read-along. Quality function deployment, translating the customer's voice into engineering language. The past 2 articles in this series establish 2 things that are in tension with each other. First, customers have wants which can be identified, understood, categorized, and prioritized with the right tools, namely the Kano model, right? That's what we identified in the Kano model. At the same time, the physical world imposes hard constraints on what a design can deliver, and optimizing in one direction always costs something in another. If you've been following along, you might be wondering how these 2 realities get reconciled in practice. How does a design team take a prioritized list of customer wants and turn it into actual design specifications while keeping the trade-off landscape visible throughout the process? Essentially, how does design emerge from knowledge of customer desires? It turns out that the translation from customer language to design language is one of the most consequential and most poorly executed steps in the entire product development process. If done well, it produces a design brief that is both customer grounded and technically executable. If done poorly, it produces a product that technically meets its specifications and still manages to disappoint the people it was built for. The gap between those 2 outcomes is wider than most product teams realize, and closing it requires rigor and structure rather than genius and intuition. The voice of the customer. Before you can translate customer wants into technical specifications, you have to capture those wants in a form that is usable. This is the domain of the voice of customer work, commonly abbreviated as VOC. Collecting the voice of the customer is not simply a matter of sending out a satisfaction survey or reading through product reviews. Those inputs have value, but they tend to surface symptoms rather than causes, and they reflect the experience of existing products rather than the requirements of new ones. We've, of course, already encountered VOC in the Kano model. The Kano model is just one approach to VOC, and I started with it because I find it extremely helpful to understand the dynamics of customer wants. But VOC writ large is a more encompassing idea and practice which we should give a bit more attention to. Fundamentally, VOC is structured listening. It involves direct customer interviews, contextual observations, sometimes we call that ethnography, focus groups, and in some cases the kind of paired survey methodology we discussed in the first article when we covered the Kano model. The goal is not to collect opinions, but to uncover the underlying needs that customer opinions point toward. A customer who says a carpet cleaner is too heavy is expressing a frustration, but the underlying need is ease of use during extended cleaning sessions. Those are related but not identical, and the distinction matters enormously when it comes time to write a specification. This is a reminder of kind of that old adage, nobody wants a 1/4-inch drill bit, they just want the 1/4-inch hole, right? So let's not confuse the needs of the customer with the thing itself. The raw output of VOC work is typically a list of customer statements, verbatim or paraphrased, describing what customers want, what frustrates them, and what would make their experience even better. These statements are sometimes called customer requirements, customer needs, or simply the voice. They are expressed in customer language, which tends to be qualitative, contextual, and occasionally vague. Easy to use is a voice of the customer statement. Lightweight is a voice of the customer statement. Doesn't leave streaks, to use this carpet cleaner example, is a voice of the customer statement. None of them is a specification yet. They are raw material that the design process needs to refine, right? So the engineers have the job of determining what is lightweight. How is that confused with heavyweight? Easy to use. What does that mean to an engineer? How do you design easy to use, right? These are the issues. This is the gap that I'm trying to paint for you, which we're trying to overcome with quality function deployment in the House of Quality. The discipline of VOC is making sure that the raw material is complete and representative before the translation process begins. Missing a customer requirement, overweighting one type of user, or focusing only on current customers rather than potential ones can introduce bias into the process that propagates all the way through to the final design. The output of VOC is only as reliable as the inputs that generated it, and most organizations underinvest in this step relative to the downstream engineering work it is meant to inform. The translation problem. The core challenge is taking this VOC and translating it into specification for design. After all, customer language and engineering landscape describe the same product from fundamentally different perspectives, and those perspectives do not map onto each other neatly. A customer says they want a vacuum cleaner that is easy to push across the carpet. An engineer needs to know the rolling resistance of the wheel assembly in newtons, the coefficient of friction between the base plate and carpet fiber, and the maximum push force that a typical user can comfortably sustain over a 30-minute cleaning session. How do you map those? Both descriptions are about the same physical reality, but one is expressed in terms of human experience and the other in terms of measurable physical qualities. Getting from the first to the second without losing the intent of the customer requirement is genuinely difficult, and it requires a deliberate process rather than an informal one. So that seems very technical, almost overly technical, but it's trying to paint this picture of how an engineer is going to approach the needs and wants of a customer is through a quantitative method, right? They have to choose materials that have tensile strength weights, and how heavy it is, how big it is. Are we using plastics? Are we using metals? So they're making all of these design considerations based on what they're hearing from the customer. They have to be able to translate how the customer speaks about the product itself into quantitative means so that they can make true design decisions. How this mapping exercise usually fails is something called specification drift. The design team receives the voice of the customer, translates it informally into technical requirements, and somewhere in the translation, the original customer intent gets compressed or lost. The customer wanted easy to maneuver in tight spaces. The engineering requirement became minimum turning radius of 18 inches. The product ships with a turning radius of 17 inches. The team declares success against the specification, and the product reviews still describe it as hard to maneuver in tight spaces. What went wrong is that the specification captured one dimension of the original customer want, but not all of it. Maneuverability in tight spaces is not merely about turning radius, but also depends on other aspects of the product, say hose flexibility, wheel placement, handle ergonomics, weight, right? So it's not just one dimension. There's multiple things that go into every one of our customer wants and desires. The translation was too narrow and technical. The narrowness was invisible because no one built a map between the customer requirement and the full set of engineering characteristics that need to respond to it. The mapping process is exactly what quality function deployment is designed to provide. Quality function deployment. Here we are. We're halfway through the article. We're getting to it now. Quality function deployment, known almost universally by its abbreviation QFD, is a structured method for translating customer requirements into technical specifications in a way that preserves the connection between the two throughout the design process. It was developed in Japan in the late 1960s, introduced at Mitsubishi Shipyard in Kobe, and subsequently adopted by Toyota and a wide range of manufacturers who found that it produced designs with fewer late-stage revisions and stronger market receptions. By the way, if you see late-stage revision, read that as money. It's much, much easier to revise a design earlier in the process than later on when it's close to market. The core insight behind QFD is that every technical decision in a product design should be traceable back to a customer requirement, and that the relationships between customer requirements and technical characteristics should be made explicit rather than assumed. QFD is not a single tool, but a family of connected matrices that can be applied across the entire product development process, from initial concept through production planning. In practice, most teams encounter QFD through its first and most prominent matrix, which is called the House of Quality. That's kind of what we're going to talk about. The House of Quality is where the translation from customer language to engineering language actually happens, and it is worth understanding in some detail. As a side note to our topic, you can use QFD internally too, not just customer facing. So after your product designs have been finalized, you might apply the QFD to your manufacturing processes to understand what is required to build the products themselves. This is actually what QFD was developed for, the development of quality within an organization to ensure that everything works together to support the needs of the customer. And I think that's kind of cool, right? So we can use QFD, we can use this thing called House of Quality to understand how the customer requirements map to engineering specifications. And then we can take those engineering specifications and say, well, what does our machine need to be able to do all of these machine specifications? And then we can say, well, what does our factory need to do so that we have all of these machines? And what does our enterprise need to do so that it can support all of these factories? And that's actually kind of the full deployment of this thing called quality function deployment. The House of Quality. The House of Quality gets its name from its visual structure, which resembles a building with a triangular roof sitting atop a rectangular body. It is a matrix, but a matrix with several distinct regions that work together to capture not just the what and the how of product design, but also the relationships between them and the trade-offs they imply. Walking through each region in order is the clearest way to understand how the tool works and why the structure is the way that it is. So here's a little picture. Essentially, I'm going to skip some of this paragraph for brevity's sake, but essentially what we care about here is listing in this what's category, these blue column headers, all the things that the customer wants, the customer needs. And then we can rank them in importance from 1 to 10. Is this the most important? Is this the least important? Okay, that's what the customer desires. That's what the customer wants. Now, up top, not this roof, not this triangular section, but up top, we can do the same thing with specifications. How are we going to do this, let's say, in terms of material selection, in terms of tensile strength, in terms of weight, in terms of volume and the size of the thing, right? So all of these are kind of technical dimensions. And then what we do is we come down here to kind of the living room where these two columns and rows intersect, and we determine how important a technical specification is in meeting the customer demands. Okay, so if I want, let's say, longevity as something in my customer needs for, let's say, a vacuum cleaner, well, then my materials are probably going to be metal over plastic, and my, tensile strength is probably going to be larger than if I didn't care about the longevity of the product. And also vice versa, there might be some other things like turning radius, a dimension that we've already mentioned, that really has no impact on this dimension of, let's call it, longevity, right? Regardless of if my vacuum cleaner turns with 17 centimeters or 35 centimeters, is really not going to have any impact in how long the vacuum cleaner or the carpet cleaner lasts, right? There's no relationship between those things. Now, The last thing, and maybe I'll come back to this in the paragraph, the last thing we want to look at is this roof, which is how are the technical specifications related to one another. So for instance, if I have something that is metal, well, that is going to be positively correlated with weight, right? The more metal I use, the stronger the correlation is with weight. Same with robustness. It's strongly correlated, but it might have a negative correlation with some of the things that might make it easy to maneuver. The ergonomics, the size of the thing, right? The weight of the thing, as we mentioned, might also impact the ease of use. So that is a very quick overview of the house of quality. I'm going to jump back in. I'm going to jump back in down at the roof here for the paragraph. But essentially, I just went through the things that we care about in terms of the house of quality. The roof of the matrix is where the trade-offs from Article 2, when we were talking about design trade-offs, of this series show up explicitly. And for my money, this is the part that I find most interesting and exciting. The triangular roof section maps engineering characteristics against each other and identifies where they conflict. Improving one characteristic helps another, which is a positive correlation, marked with a plus sign, or improving one characteristic hurts another, which is a negative correlation marked with a minus sign. For the carpet cleaner, reducing total unit weight is positively correlated with ease of maneuverability, because a lighter unit is easier to push and lift, but reducing weight may conflict with suction power because the motor and impeller assembly that generates strong suction adds mass. The roof makes the conflict visible on paper in the planning phase before it becomes a problem in the lab or on the production floor. The value of the house of quality. It is worth stepping back and asking what problem this tool is really solving, because the house of quality can look, at first glance, like an elaborate way to document things a good engineering team already knows. This reaction misses the point completely, however. The house of quality is not primarily a documentation tool, but a communication tool and a decision-forcing mechanism. Product development involves multiple functions with genuinely different perspectives and priorities. Marketing understands what the customers say they want. Engineering understands what is physically achievable. Manufacturing understands what can be produced and scaled reliably. Each of these functions bring legitimate expertise to the table, and each of them also brings the natural tendency to optimize for the things within their own domain. The house of quality creates a shared artifact that all of these functions can look at together, argue about together, and ultimately align around. The relationship matrix in particular forces conversations that might otherwise never happen. When marketing sees that a customer requirement, which was rated as highly important, has no engineering characteristic with a strong relationship to it, that is a signal that something is missing, right? So if I say I care about making it feel good, making me feel good, I say, well, I don't know what that is in engineering terms. Well, that's going to trigger a discussion about how to actually produce this feeling in the product itself. When engineering sees the two highly weighted customer requirements pull in opposite directions through the roof matrix, this should trigger a conversation about trade-offs. And conversely, if there are two highly weighted customer requirements pulling in the same direction, this should trigger a conversation about procuring the best, highest quality materials regardless of cost, because the customer is going to reward you for your efforts. The house of quality also creates accountability over time. When a product ships and a customer requirement is not well served, the team can return to the matrix and ask where the breakdown occurred. Was the customer requirement missing or underweighted? The priority was not high enough? Was the engineering characteristic that should have addressed it poorly selected and specified? Was the target value set too conservatively? Was the relationship between the requirement and the characteristic overestimated? The matrix provides a structured place to diagnose the failure, rather than simply experiencing it as a vague sense that the product missed the mark. Conclusion. Quality function deployment is not sexy, it is not exciting, and as far as product development is concerned, it is probably the most technical and driest aspect of the whole process. Nevertheless, it is necessary. If there is no way to map the desires of the customer to the technical specifications of the product, or if the mapping is inconsistent and highly variable, the result will be catastrophic for the product and for the customer. Indeed, the product development process itself may be responsible for the success or failure of the product altogether. I don't like to lean too heavily on or speak too often about the tools, but in this case, the House of Quality is the right tool for the job, particularly paying attention to the roof, which allows us to visualize the way customer expectations support or conflict with themselves. Taken together, QFD and the House of Quality are exactly the right thing to do to bring the wants and expectations into a designed reality. So as always, you finished the article, it was free. So also is this podcast. Please share this publication, leave a comment, subscribe now. I really appreciate it. I'm doing more to produce more content for you as free subscribers and also for paid subscribers. I just put up a new simulation looking at design trade-offs. So if you're interested in that, please become a paid subscriber. And I'm really enjoying doing these podcasts. I'm trying to do it whenever I have free time. So please let me know, give me feedback if you enjoy these so I can continue to do them. Thanks for tuning in. Please subscribe. Thanks for the support.